name is Teacher John. Welcome to the science class for primary 7. In our previous lesson, we looked at secondary cells as sources of electricity. We said secondary cells are cells that can be recharged. You can recharge them. That's why we call them secondary cells. They can be recharged. And we gave examples of secondary cells. For example, we say car batteries. Car batteries are examples of secondary cells. We also mentioned phone battery. Phone batteries are also examples of secondary cells. Then we also mentioned solar batteries. Solar batteries. So, these are the three examples of secondary cells. We said secondary cells are cells that can be recharged. So, you can take a car battery once it loses electricity and you charge it. The same applies to phone batteries. That's why we charge our phones once they run out of power. We charge them. So they are examples of secondary cells. Now remember, we are still looking at sources of electricity. We mentioned very many sources. This car battery is a source of electricity, a phone battery, a solar battery. Wind is a source of electricity, even including dry cells. Dry cells are also sources of electricity. So we looked at all those sources of electricity. We began by looking at a dry cell. After a dry cell, we looked at a wet cell. So today, the next source we are going to look at is chemical battery. A chemical battery. A car battery is an example of a chemical battery. I repeat, a car battery is an example of a chemical battery. It stores chemical energy, then it produces electric energy. What do I mean? When a chemical battery or a car battery is not in use, the form of energy it stores is called chemical energy. But the moment it is put into use, the moment you connect it to an electric appliance, like a TV, a radio, a bulb, and so on, all those are electric appliances. Electric appliances are devices that use electricity. So once you connect them to a chemical battery or a car battery, it will start producing electric energy. That's what we are saying, a car battery produces electric energy. In other words, the moment you put it to use, it will convert chemical energy into electric energy. I have something to note here. A chemical battery changes chemical energy into electric energy. A chemical battery or a car battery changes chemical energy into electric energy. Then, a chemical battery or a car battery has a positive terminal and a negative terminal. A car battery has a positive terminal and a negative terminal. A positive terminal and a negative terminal. A positive terminal is represented by a plus sign. Then a negative terminal is represented by a negative sign. So if you go on a car battery and you find a plus sign, that one represents a positive terminal. Then a negative sign, that one represents a negative terminal. For example, you have something like this. This is an example of a car battery. You find here we have positive terminal, then here we have negative terminal. So I've said positive terminal is represented by a positive sign or a plus sign, then a negative terminal is represented by a negative sign or a minus sign. So that is all about a chemical battery. Then maybe a question you need to ask yourself is, why is a car battery, called a secondary cell? Why is a car battery called a secondary cell? A car battery is called a secondary cell because it can be recharged. Remember, we say secondary cells are cells that can be recharged. So the reason why a car battery is called a secondary cell, it is because it can be recharged. Once it loses power, you can charge it. So you can say it can be recharged. That's why it is called a secondary cell. It can be recharged. That's why it is called a secondary cell. Then we look at advantages of using a chemical battery or a car battery. Advantages of using a car battery or a chemical battery. The advantage is already known because we said for it can be recharged. Advantages of using a car battery. Advantages of using a car battery. Now, one of the advantages of using a car battery is it can be recharged. It can be recharged. It can be recharged. That's the advantage. A car battery can be recharged. That's the advantage. With primary cells, you cannot recharge them. Once they lose electricity, that's the end of it. You cannot recharge them. But with car batteries, you can recharge them. Then the next source of, maybe before we look at another source of electricity, let's look at disadvantages of using chemical batteries. Disadvantages of using chemical batteries. Disadvantages. Of using chemical batteries. One of the disadvantages of using chemical batteries is that these chemical batteries contain an acid. They contain an acid which is harmful to human health. I repeat, the disadvantage of using chemical batteries is that it contains an acid which is harmful to the human body or to the human health. It contains an acid which is harmful to the body, harmful to the human body, or human health. So the chemical batteries or the car batteries that you see, inside them we have an acid, and that acid is harmful to human health or human body. So once that acid pours on your body, then it will burn you. In P6 we looked at causes of burns, and we said when acids come into contact with our body, it can cause burns. So that means that these chemical batteries, as much as they are important to us, they provide electricity, but once the acid inside the chemical batteries pours on our skin, then we get burned. The next source of electricity we are looking at is running water or fast flowing water. Running water or fast flowing water. Running water. Some people say fast flowing water. Fast flowing water. So water is a source of electricity. Water is a source of electricity. And the fast flowing water is used to generate hydroelectricity. Fast flowing water or running water. Running water is used to generate hydroelectricity. Fast flowing water is used to generate hydroelectricity. Now, this fast flowing water, how does it generate electricity? It turns turbines which are connected to a generator, and electricity is produced. Now, turbines are machines that are made to turn by fast flowing water. If you go to Owen Falls in Ginger, you'll be able to see the turbines where electricity is generated. So these turbines are connected to generators that help to produce electricity. Now, what makes these turbines to turn is fast flowing water. So they ask you, how does fast flowing water generate electricity? You can say running water turns turbines. Running water turns turbines which are connected to generators. Running water turns turbines running water turns turbines which are connected to generators. Running water turns turbines which are connected to generators. So once these turbines turn, they make the generator to generate or to produce hydroelectricity. Question. How does How is water used to generate electricity? How is water used to generate hydroelectricity? How is water used to generate hydroelectricity? Water turns turbines. Water turns turbines which are connected to generators. The word turbines is Turbines, turbines. So water turns turbines, and I say these turbines are connected to a generator which helps to produce hydroelectricity. The next source of electricity is the sun. The sun is also a source of electricity. The sun is a source of electricity. The sun is a source of electricity. So you can say the sun is used, or the sun provides solar electricity. 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 Now, how do we get solar electricity from the sun? We have what you call solar panels. And these solar panels trap heat from the sun. The solar panels trap heat from the sun. Then that heat is converted into solar electricity by solar cells. So we shall say solar panels trap solar energy, or you can say solar panels trap heat from the sun. Solar panels trap solar energy or heat from the sun. Then these solar panels have solar cells that convert solar panels have solar cells that convert solar energy into electric energy, or into solar electricity. Solar panels have solar cells that convert solar energy into solar electricity. So you find that on top of tall buildings, solar panels are erected there to be able to trap heat from the sun. The heat from the sun is what we are calling solar energy. So this solar energy is converted into solar electricity by the solar cells. So inside the solar panel, we have solar cells that convert solar energy into solar electricity. And you need to know why solar panels are painted with dark or black colors. The reason is to be able to trap heat from the sun. So I want to write a question. Why are solar panels painted with dark colors? That's a question. Why are solar panels painted with dark colors? The response would be to be able to trap heat from the sun. In P5, we looked at heat absorbers and heat reflectors. Objects which absorb heat are dark colored. Then those on which reflect heat are brightly colored. So dark colored objects absorb heat, then bright colored objects reflect heat. So solar panels are painted with dark colors to absorb heat from the sun or to trap heat from the sun. So we shall say to trap or absorb heat from the sun. That's why they are painted with dark colors to absorb heat from the sun. Another question you need to ask yourself is, what is the importance of the solar battery? How important or how useful is a solar battery? How important is a solar battery? Now, a solar battery stores solar electricity. 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 The spelling of the word absorb, absorb. Now, absorb heat from the sun. Now, how important is a solar battery? A solar battery stores solar electricity. That's the importance of a solar battery, is to store solar electricity. Then another question is, how important are solar cells? How important are solar cells? How important are solar cells? Now I told you that solar panels have solar cells, and these solar cells convert solar energy into solar electricity. So you can say solar cells convert solar energy into solar electricity. So it is as simple as that. So you need to know the importance of solar cells, and I told you the solar cells are found in a solar panel. Then these solar cells convert, or they change solar energy into solar electricity. If you don't want to say solar energy, you can also say heat from the sun. And there's a mistake which some people like making. And one of the mistake is when they ask you why solar panels are painted with dark colors, we say to absorb heat from the sun, not light. So solar panels don't absorb light or sunlight. The emphasis is on the word heat. They absorb heat from the sun. They can even ask you, why are they put on tall buildings? Is to be able to trap enough heat from the sun. That's why solar panels are put on tall buildings in an open place, not near trees, because if you put them near trees, then the shade will prevent heat from the sun from reaching the solar panels. So the reason why solar panels are put in an open place is to be able to get energy from the sun or heat from the sun directly. So that is about the sun as a source of electricity. Remember, we began by saying the sun is used to generate solar electricity, and we've learned how the sun can be used to generate solar electricity. So once you have a solar panel, you'll be able to get solar electricity. Maybe another thing you need to know is the uses of solar electricity. So electricity can be used for cooking, then it can also be used for lighting. So once you store solar electricity, you can decide how you want to use it. You may use it for cooking, or you may use it for lighting. So the next thing you're supposed to know is uses of solar electricity. Uses of solar electricity. We're only going to give two uses which are common. Uses of solar electricity. Uses of solar electricity. One, we've said it is used for cooking. It is used for cooking food. Then number two, it is used for lighting. And the solar electricity is commonly used in villages where we don't have hydroelectricity. So most of the villages have solar panels, and the reason why they have solar panels is to be able to get solar electricity, so they can use it either for cooking or for lighting. And this one helps to conserve the environment. It helps to conserve the environment. They can even ask you, how does the use of solar electricity conserve the environment? How does the use of solar electricity conserve the environment? So you simply say people use solar electricity for cooking instead of cutting down trees for wood fuel. Majorly in villages, people cut down trees to get wood fuel, to burn charcoal or to get firewood. But when they have solar electricity, you find that the rate at which they cut down trees for wood fuel reduces, because instead of using firewood or charcoal to cook food, they will use solar electricity. So we can put this question down and say, how does the use of solar electricity conserve the environment? How does the use of solar electricity conserve the environment? Here we shall say, people use solar electricity for cooking, instead of cutting down trees, for wood fuel. So instead of people cutting down trees for firewood or for charcoal, they use solar electricity for cooking their food. And this one helps to conserve the environment. Another answer would be solar electricity does not pollute the environment, because when you use it for cooking, it does not produce any smoke. So you can also say solar electricity does not pollute the environment. That's how it conserves it. It does not pollute the environment, or it does not produce smoke. Solar electricity does not pollute the environment. Solar electricity does not pollute the environment. And the reason why it does not pollute the environment is because it does not produce smoke. But if you cook food using firewood, a lot of smoke and carbon monoxide is produced, which pollutes the environment. So people are always encouraged to use electricity for cooking, because for it is clean. Next, we look at fossil fuels. Fossil fuels. In P.6, we looked at fossil fuels. And we said fossil fuels can be used for cooking, like coal, and fossil fuels can also be used to generate thermal electricity. Fossil fuels can be used to generate thermal electricity. Fossil fuels. And we gave examples of fossil fuels. We have only 3 examples, but before we give the examples, you can say fossil fuels are used to generate, or are used to produce thermal electricity. Fossil fuels are used to produce thermal electricity when burnt. So fossil fuels are burnt to produce thermal electricity. And we can give examples of fossil fuels. For example, we have coal, we have petroleum, and natural gas. So when you burn coal, you will get thermal electricity. Very soon we are going to look at forms of electricity, and one of the forms of electricity is thermal electricity. And thermal electricity is got by burning fossil fuel, especially coal. So you can say examples of fossil fuel. Examples of fossil fuels. Example of fossil fuels, we say coal. Number 2, we have petroleum. Then number 3, we have natural gas. Natural gas as an example of a fossil fuel. And if you cannot write the word petroleum, you can write crude oil. Crude oil. Then from petroleum, we get petroleum products like diesel, jet fuel, petrol, paraffin, and so on. So those are products of petroleum. But the fossil fuel is petroleum or crude oil. Then we have coal and natural gas. So when you burn coal, you can get thermal electricity. Then lastly, we look at uranium. We look at uranium as a source of electricity. Remember, we are still looking at sources of electricity. Sources of electricity. Where do we get electricity? So electricity can be got from different sources, and they are the ones we are looking at. And every source has a form of electricity it produces. So the next source of electricity we are looking at is called uranium. Uranium. Now uranium can be used to produce, or is burnt to produce nuclear electricity. Uranium is burnt to produce nuclear electricity. Produce nuclear. You can call it nuclear or atomic electricity. Uranium is burnt to produce nuclear or atomic electricity. Uranium is burnt to produce nuclear or atomic electricity. In P.6, when we are looking at resources, we say uranium is a resource, is an energy resource. And which energy resource does it produce? Atomic electricity or nuclear electricity. Uranium can also be used to make atomic bombs. Uranium can be used to make atomic bombs. So in case they ask you uses of uranium, you can say uranium is used to produce, is burnt to produce nuclear or atomic electricity. Then you can also say uranium is used to make atomic bombs. Uranium is used to make atomic bombs. And uranium is an energy resource. After looking at electricity and magnetism, our next topic will be energy resources. We shall look at what energy resources is, and we shall still discuss uranium as an energy resource. So uranium stores chemical energy. That's something you need to know. Uranium stores chemical energy. Uranium stores chemical energy. Uranium stores chemical energy. Then this chemical energy, when is converted into nuclear electricity, once you burn uranium, it will be converted into nuclear electricity. So next we look at wind. Wind as an energy resource or as a source of electricity. So wind is also used to generate electricity by turning windmills. Wind is used to generate electricity by turning windmills. Wind is used to generate electricity Wind is used to generate electricity by turning windmills. You looked at windmills in primary 3, including primary 6. We learned about windmills. We gave uses of windmills. And we said a windmill can be used to generate electricity. Apart from generating electricity, windmills can also be used to grind grains like maize, millet, sorghum, and so on. Then windmills can also be used to draw water from underground. So it can help in pumping water from underground. So once the windmill is turned by wind, it can either grind grains, generate electricity, or draw water from underground wells. So that's how wind is used to generate electricity. So in case you are asked how wind is used to generate electricity, you simply say wind turns windmills to generate electricity. That's why we are saying wind is used to generate electricity by turning windmills. By turning windmills, there is an activity on page 15. There's an activity there about the lesson we have learned. So make sure you attempt that activity. In case you need any help, you can always get in touch with me. Next, we look at types of electricity. We are now done looking at sources of electricity. Our next lesson is going to be on types of electricity. Types of electricity. Now we have majorly two types of electricity. We have two types of electricity. Only two. So next look at types of electricity. Types of electricity. Types of electricity. One, I've said we have two types of electricity. One is current electricity. Current electricity. Then number two, we have static electricity. We have static electricity. We have current electricity and static electricity. Let's begin with current electricity. You need to know what current electricity is. Current electricity. Current electricity. Now, current electricity is the type of electricity that involves the flow of electrons. The spelling of the word electrons is written like this. Electrons. I repeat, current electricity is the type of electricity that involves the flow of electrons. I repeat, current electricity is the type of electricity that involves the flow of electrons. Current electricity is the type of electricity that involves the flow of electrons. Current electricity is a type of electricity that involves the flow of electrons. Okay, so I want to see how electrons flow and how current flow. So our next heading is the flow of current. The flow of current. The flow of current. Current flows from the positive terminal to the negative terminal. Current flows from the positive terminal. Current flows from the positive terminal to the negative terminal. Current flows from the positive terminal to the negative terminal. I told you positive terminal has a plus sign, negative terminal has a negative sign. So current flows from the positive terminal to the negative terminal. Now, our current is also known as electricity. So in case they ask you how does electricity flow in an electric circuit, you simply say it flows from the positive terminal to the negative terminal. The word current can also mean electricity. You can also call it electric current or electricity. So it flows from the positive terminal to the negative terminal. We're going to draw a diagram showing the flow of current. A diagram showing the flow of current. Diagram showing the flow of current. So we're going to draw an electric circuit. An electric circuit is a path through which current flows. I repeat, an electric circuit is a path through which current flows. So we shall draw a dry cell. Then in this dry cell we shall also draw their bulb. Then we show the flow of current. Then we shall draw a bulb here. That's a dry cell. Remember, we looked at a dry cell as a source of electricity. I told you a positive sign represents the positive terminal, then the negative sign represents the negative terminal. So you connect a bulb on the positive terminal, then you connect your conducting wire. This one is called conducting wire. Conducting wire. That one is a bulb giving out light. So if we come to the flow of current, we say current flows from the positive terminal to the negative terminal. Current flows from the positive terminal to the negative terminal. So you draw an arrow to show the flow of current. To show that current is flowing from the positive terminal to the negative terminal. Then you can write here the flow of current. The flow of current. So that one shows the flow of current, because we say current flows from the positive terminal to the negative terminal. Then this one is a bulb, light bulb, light bulb. Then lastly, we look at the flow of electrons. Look at the flow of electrons. Now, electrons flow from the negative terminal to the positive terminal. The flow of electrons. The flow of electrons. Then we shall say electrons flow from the negative terminal to the positive terminal. Electrons flow from the negative terminal to the positive terminal. Look at a diagram to show the flow of electrons. A diagram showing the flow of electrons. So we again draw a dry cell. On this dry cell, we connect the bulb. Put here the positive sign, negative sign. We connect a bulb. Bulb will give out light. Then we put a conducting wire. This conducting wire, the role of a conducting wire is to to carry electricity. That is a bulb. Sometimes it is called a light bulb. It is called a light bulb. Light bulb. This one is conducting wire. Then we've said that electrons flow from the negative terminal to the positive terminal. So that arrow shows the flow of electrons. So flow of electrons. This arrow shows flow of electrons. Flow of electrons. Then you can simply say electrons flow from the negative terminal to the positive terminal. I say the positive terminal is represented by the plus sign, negative terminal is represented by the negative sign or minus sign. Then this one is the conducting wire. Conducting wire, as simple as that. So that is a diagram showing the flow of electrons. Next we shall look at types of current, electricity. I think that one we shall look at it in our next lesson. Types of current, electricity. We have only two types of current electricity, and that is direct current and alternating current. Types of current electricity. Types of current electricity. I said we have two types. One is direct current. Direct current. Then number two, we have alternating current. Alternating current. As simple as that. So those are the two types of current electricity. We have direct current and alternating current. Those are the two types of current electricity. And after that, we shall also look at what direct current electricity is and what alternating current electricity is. Otherwise, thank you so much for being attentive in my lesson. Don't forget to attempt the activity on page 15. You should attend to that activity. If you don't have workbooks, please make sure you come to school and buy the P.7 workbooks. That one will help you to follow our lessons and understand them properly. In case you need any help, you can reach me on 0705 74 1638. That number is on WhatsApp. Any question will be answered. Otherwise, God bless you.